Okay, so for this bell ringer, I am not going to go over it. I will walk you through it, but I am not going to go over it exactly. So whenever we're talking about perpendicular, we have to do opposite reciprocal. So instead of being positive, now it's going to become negative. Instead of being 3/4, now we're going to become 4/3. We're using this point slope formula. Plug the 3 in, plug the -2 in. A negative and a negative gives me a positive. We distribute 3/4 x minus 8/3 because a negative times a positive is a negative. We add 3 at the end and we get y equals -3/4 plus 1/3. For the one here, we're talking about an angle bisector, which means it's cutting this angle in half. So half of 260 is 130. So we can set x squared plus 9 equal to 130. Subtract 9, find the square root, and x equals 11. For this one, we're looking for the inverse of the conditional statement, which means it's not P, not Q. So not equilateral, and does not have 3 congruent sides. So 2 and 4. For this one here, we know GO is a straight line. I'm looking for angle J. So anything on a straight line, you can always do 360 divided by 5 because this has 5 sides, or 360 divided by 8 because this has 8 sides. So that gives me 72 and 45. Now I have this triangle here. So I can do 180 minus the 41 degrees minus the 72 to give me 67. So this angle here will be 67. Well, those two angles are vertical angles, so this one's also 67. And we already did 360 divided by 8 because this is an octagon, which gives me 45. So 180 minus the 67 that we have for Z minus the 45 that we have for H gives me 68. So that is our bell ringer. So today's title, in case you don't have it, and the dates we learned this lesson. Now, inequalities in one triangle. Something that I want you to copy down is this down here. This is what I want you to write down. Now, we learned about inequalities in one triangle. We learned that angle 1 is the sum of angle A plus angle B. So the inequality theorem states that angle A is smaller than angle 1 and angle B is smaller than angle 1. That's all this theorem states. So for example, if we're trying to find the measure of angles that are less than 14, I'm going to look at my angle 14. I am going to create my straight line to get the triangle. A straight line to get the triangle. And this is my triangle. Now, which angles would I have added to get 14? Well, that would be 4 and 11, which means angle 4 and angle 11 are less than angle 14. Go ahead and try the next two. Pause the video and unpause it once you're ready. We're looking for 16. Again, I follow the angle, create a straight line to create my triangle. The ones that I would add to get 16 would be 2 and 10. Therefore, it is angle 2 and angle 10. This one, we're looking for 15. And that would be 7 and 12. So theorems on angle side relationships. Now take the time to go ahead and read these here. Go ahead and read the theorems themselves. And then once you read them, unpause the video so we can continue going over that. So I know sometimes it seems like a little confusing, but all this theorem is saying is that I know that xy is 9. And then I know that YZ is 7. So what's bigger, 9 or 7? Well, 9 is bigger. So if 9 is bigger, then Z is bigger than X. That's all this theorem is stating. Vice versa for the converse. I know this is 45. So that goes with JL. I know this is 110. So that goes with KL. What's bigger, KL or JL? Well, 110 is bigger, so therefore KL would be bigger than JL. So, smallest to largest, angles in order from smallest to largest. So what's my smallest side here? My smallest side is AB, which is 11.1. And across from it is C. So angle C is my smallest. Then, second smallest is 14.3. And that next one is A. And then my my biggest is 15.7, which is angle B. So go ahead and pause the video and solve the next one on your own. Go ahead and pause the video and solve the next one on your own. So my smallest here is 18.5. So it's T. Oh, I made a mistake. It's not 18.5. My smallest is actually 17.4. So it should be X, then T, and then V. XTV. Triangle inequality theorem, all it's stating is that if I were to add any of these sides together, it should be greater than the third one. So this plus this should be greater than that. This plus this should be greater than this one. And this plus this should be greater than that one. So how that would look like is, for this one, I need to explain if it's possible to form a triangle. Well, I'm going to do 6.5 for side 1 plus 6.5 for side 2 greater than 14.5, which is side 3. And then I do 6.5 for side 2 plus 14.5, which is side 3, greater than side 1. And then side 3 plus side 1 greater than side 2. I plug all of these in the calculator. 6.5 plus 6.5 is 13. 13 is not greater than 14.5, but the other two do work out. But it's still not a possible triangle because because 6.5 plus 6.5 is not greater than 14.5. So go ahead and try the we do and the you do. Pause it, try it, and then come back. For this one, you should have done 6.8 plus 7.2 greater than 5.1. 7.2 plus 5.1 greater than 6.8. 5.1 plus 6.8 greater than 7.2. And all of these work out, so it is possible. Last one. 8.5 plus 11.5 is greater than 20.5. 11.5 plus 20.5 is greater than 8.5. And 20.5 plus 8.5 is greater than 11.5. This one does not work out because this gives me a total of 20. And 20 is not greater than 20.5. So not a possible triangle. Now, let's take a look here. So in triangle PQR, PQ is 7.2, QR is 5.2. Find the measure that cannot be PR. Now, technically what we would have to do here is exactly what we did here. All these three, but for every single answer choice. And that's going to take forever. So there's a trick to this. There's a trick. So I can set up a range of possible lengths. And the possible length range can be done by subtracting and adding our two sides. So 7.2 minus 5.2, which is 2. And then 7.2 plus 5.2, which is 12.4. So now I'm looking for a length that is in between P and R. 2 is in between 7 and 12. 9 is in between 2 and 12. 11 is in between 2 and 12.4. But 13 is not. And thankfully, I'm looking for cannot. So it is D. So go ahead and try the UE do and the U do, and then come back once you are done. So again, we're setting up a range, and I'm still looking for cannot. So 12 minus 10, which is 2, and 12 plus 10, which is 22. So 2 and 22. So the ones that would work here that are in between are 20 and 19. 23 and 2 are not. The reason 22 is not part of it is because this symbol does not have an equal sign. It is not less than and equal to. It's just less than. So 2 and 22 are not included. So therefore it is A and C. Last one. We're doing the same thing. We're setting up a range. And we're going to do 9 minus 6, which gives me 3, and 9 plus 6, which gives me 15. So it has to be in between 3 and 15. So 4 works, 9 works, 12 works, but 16 doesn't. And that's what I'm looking for. So all that we just did right now was finding the range. So now they can asking you for the actual range with 18.3 and 15.6. So that means that it has to be my subtraction and then my addition. So 15.6 minus 8.3 gives me 7.3. And 15.6 plus 8.3 gives me 23.9. So my answer is C. Does that make sense? I hope it does. If it doesn't, let me know. Same thing here. We're looking for 12.2 and 9.5. Now, there was a mistake on yours. This ends up being 3 point something. So I just want you to box your final answer. So I know that 12.2 minus 9.5 is 2.7. And 12.2 plus 9.5 is 21.7. So I know it's going to be 2.7 less than n less than 21.7. So you don't have to worry about these because they weren't copied down correctly. But this would be your final answer. Last one. 7 and 12. 7 plus 12 is 19. 12 minus 7 is 5. And that answer is D. Please be careful with these. Notice how they give you 12. Notice how they give you 5 and 12. They're trying to trick you. Notice how they give you 7 and 19. They are trying to trick you. So subtract them and add them. Now let's talk about the hinge theorem. So the hinge theorem, make sure you copy this. Go ahead and read it and copy the notes that I underline. Those are the ones that need to be filled in into your paper. And go ahead and read this theorem. Now, what's important about this theorem is that it's stating that if AB is congruent to FG and AC is congruent to FH, I'm going to take a look at my angles. One's 30 and one's 43. So what's bigger, 43 or 30? Well, 43 is greater than 30. So that means that BC would be greater than GH. Now, go ahead and copy this one down. PR, QR, and it's saying the exact same thing but backwards. So, how does that look? Well, using the hinge theorem, compare the measures of AD and DB. Well, AD goes with 70. DB goes with 68. So what's greater, 70 or 68? Well, 70 is greater than 68. Therefore, AD is greater than DB. And that's it. Go ahead and do the you do. Circle it, A, B, C, or D, and come back when you're done. For the you do, I'm talking about angle JKM, which belongs to 6.1, and KML, which belongs to 7.2. So 7.2 and 6.1. What is greater? Well, 7.2 is greater than 6.1. So therefore, KML is greater than JKM. But if you notice, none of them start with KML. So I just need to flip it. Let this one go first. JKM. If I flip this, I also need to flip that. It's less than KML. It's still saying the same thing. So your answer would be B as in boy. And we are done. That is it for this lesson. If you have any questions, ask your teacher.